Today's objective is I will be able to rationalise the denominator. I'll explain what that means in a moment, but right now what I would like you to do is a little warm-up, 5 quick questions. Press pause, have a go, and then we'll go through them. Okay, simplifying. 2 numbers that times together to make 24, one of which is a square number. 4 times 6 becomes 2 root 6. Root 3 times root 3 is 3. 5 root 2 times root 3 is 5 root 6. Here I do 10 divided by 2, which is 5. Root 10 divided by root 2 is root 5. This one here, 2 times 3 is 6. Root 5 times root 5 is 5. So 6 times 5 is 30. Key points for today. Rationalising the denominator means getting rid of the surds from the bottom of the fraction. So in our very first lesson I mentioned that surds were irrational numbers. So by rationalising the denominator means we're making a surd, which is irrational, into a rational number. For the simplest type, you do this by multiplying the top and the bottom of the fraction by the surd. So I'm going to do a worked example for you to just explain what I mean by that. So our first worked example is this, 2 over root 8. So I want to get rid of the root 8 at the bottom of the fraction, and we know that if we times a root by itself, or a surd by itself, it becomes the integer value. So if I do 2 times root 8, I get 2 root 8. Root 8 times root 8 is 8. Okay, I don't care if there's a surd at the top. What I'm worried about is getting rid of the surd at the bottom. Okay, this one would simplify. You could cancel this down. So 2 goes into 2 once and 8 4 times. So I get root 8 over 4. Okay, I have another example for you here. So I have 3 over 2 root 3. So in order to get rid of the root 3 at the bottom, I times it by root 3. Now I don't have to times the whole thing by 2 root 3, I can just do the surd. So this becomes 3 root 3 at the top, and 2 times, well, root 3 times root 3 is 3, so it becomes 2 times 3, which leaves me with 3 root 3 over 6, which would cancel down. 3 goes into 3 once and 6 twice, which becomes root 3 over 2. Here's 2 for you to do. Okay, let's go through these then. So the first one, you need to times the top and the bottom by root 5. So I get root 5 over 5. And the second one here, times the top and the bottom by root 3. So I get root 3 over 3 times root 3 times root 3. Root 3 times root 3 is 3. 3 3s are 9, so my final answer is root 3 over 9. Okay, I have some practice questions for you to do here. Have a go, press pause, and then come back to mark them. Here are your answers. Mark your work carefully. Okay, our next key point. If the denominator is an integer and surd, example 1 bracket root 2, use the difference of 2 squares to eliminate the surd. So what I mean by that is if the denominator was 1 add root 2, if we times it by 1 minus root 2, we will get rid of the surds. If it was 1 minus root 2, we multiply it by 1 add root 2. That will also get rid of the surd. So let's have a look at a worked example together, and that might make a little bit more sense. So I've got 1 over 2 add root 2. So in order to get rid of my surd here, I need to times the top and the bottom by 2 minus root 2. Okay, so the top bit's quite easy to do here. We've got one lot of that, which is just 2 minus root 2. Now the bottom bit, this is a quadratic. If you want to put them in brackets, you can. So I need to draw a grid. So I get 2 add root 2 and 2 minus root 2. Two times 2 is 4. 2 lots of root 2 minus 2 root 2 minus root 2 times root 2 is minus 2. So what you should see happens here is when you write them out, two root 2 minus 2 root 2 disappears. So these eliminate each other and you're left with 4 minus 2, which is 2, which means that you have rationalised the denominator. Okay, here's one for you to do. Press pause and then we'll go through it. Okay, so you need to times the top and the bottom by 1 minus root 7. So one lot of 1 minus root 7 is 1 minus root 7. And then if you draw your grid, you should get 1 root 7 or just root 7 minus root 7 and minus 7. So these two will eliminate each other. You're left with 1 minus 7, which is minus 6. So you have rationalised the denominator. Okay. I have some practice questions for you to do now. So if you press pause, have a go, and then we will go through them. Okay, so I'm going to go through these with you now. So the first one we've got here is you're going to times the top and the bottom by 1 add root 7. Okay, now when you're going to times this, don't forget, because there's a 5 here this time, you need to times both terms by 5. So the top becomes 5, add 5 lots of root 7. Bottom bit, if you draw out your grid, you get 1 minus root 7, get 1 plus root 7. So I get 1 minus root 7 plus root 7 and minus 7. These will cancel out. 1 minus 7 is minus 6. So you get all of that over minus 6. Next question. So we're going to times the top and the bottom by 2 minus 3 root 2. So times over the top, 2 lots of root 2 is 2 root 2. Root 2 times 3 root 2. So root 2 times root 2 is 2. 3 lots of 2 is 6. So I get minus 6 there. And then if I do my grid for this bottom bit of the fraction, two times 2 is 4. 2 lots of 3 root 2 is 6 root 2. 2 lots of 3 root 2. Sorry, that should be a minus there. So 2 lots of minus 3 root 2 is minus 6 root 2. And then root 2 times root 2 is 2. 3 3s are 9. So 9 2s are 18, and you've got your minus sign there, so this is minus 18. These will cancel, so I'm left with 4 minus 18, which is minus 14. Now just check here, because you can actually simplify this further, because we've got 2, a 6 and a 14. 2 goes into all of them, 2 goes into that once, 3 times, 7 times. So my final answer is root 2 minus 3 over minus 7. Okay. Next question then. So this time I'm going to times the top and the bottom by 1, add root 2. Now be careful, because now we've got double brackets at the top and the bottom, so you're going to have to draw out 2 grids. So the numerator becomes 1 root 2 times 1 root 2. So 1 times 1 is 1, root 2, root 2 and 2. So when I simplify that, 2 add 1 is 3, root 2 add root 2 is 2 lots of root 2. So that's my numerator. Doesn't matter that there's a surd in there, because the point of rationalising the denominator is to get rid of the surd at the bottom. So 1 times 1 is 1, root 2 minus root 2 and minus 2. These two cancel out. 1 minus 2 is minus 1, so there's my denominator. Okay, and the last one here is a proof question. Now, don't be put off by the fact that it says prove. All you need to do is do that question, and that should be your answer. Okay, so what we're going to do is start by squaring this bracket. The first thing I'm going to do is square this bracket. So 1 root 3, 1 root 3. 1 times 1 is 1, root 3, root 3, 3. So when I simplify that, 3 add 1 is 4, root 3 add root 3 is 2 root 3. So now we need to times 2 minus root 3 by our answer. So I've got 2 minus root 3 times by 4, 2 root 3. So 4 times 2 is 8. 2 lots of 2 root 3 is 4 root 3. 4 lots of minus root 3 is minus 4 root 3. And minus root 3 times 2 root 3 is minus 6. So these cancel each other out. 8 minus 6 is 2. So let's put this back together. So I've got 2 at the top over root 2. Now, we want the answer as just root 2. So what we actually need to do now is rationalise the denominator. So I times the top and the bottom by root 2. This becomes 2 root 2. This becomes 2. And then these cancel out, so I am left with root 2. So if you show all of your workings, you show that the answer is the same, you have proved your point. Okay, so what you need to do now is download your exit ticket, show your workings out, take a picture of it and send it to your teacher.